This is Algebra 1, Lesson 27A, more on the distributive property. We're going to do examples 27.1 through 27.4. First, a little bit of a reminder about what the distributive property is. Now, if you were to do a problem like this, you would normally just go ahead and do what's in the grouping symbols, the symbols of inclusion, and you would say that that is the same as 9. You'd leave it in the parentheses and copy down the 4. Then you could go ahead and do that multiplication, and you would get 36 as your answer. And that's the right way to do that. That's good. Now, you could do it another way, and the other way would show that the distributive property works. So let's distribute the 4 to the 2 and the 7. So we're going to multiply 4 times 2, and then we're going to add to it 4 times 7. 4 times 2 is 8. We'd bring down the plus sign. 4 times 7 is 28. And when you add the 8 and the 28, you would get 36. So you get the same answer either way. But you can see that this way obviously is a faster way and the best way to do it. So why do we even have this way, right? Why would we even use this? Well, I'm going to answer that question here. If you have this problem, which you've done, so problems like this, you can't do what's inside of the symbols of inclusion because you don't know the values of x and y, and those are not like terms. So we can't do that. So we have to be able to do it with the distributive property. So let's distribute that. So we would have the 4p times the x plus the 4p times the 3y. So the 4 times the 3 would be 12, and then p times y is py. So that's how you would do that problem using the distributive property. Okay, now today's lesson is going to go on into a little more complicated problems that have that are just a little more complex. So you can see, I would always check, can I do what's inside of those parentheses? Because if so, that's the faster route, okay? But I can't because they're not like terms. They don't have the same variable raised to the same power. So I'm going to have to use distributive. Now I've got to make sure I distribute to both of the terms on the inside. This is a term and this is a term. Okay, so I'm going to do, and I'm going to write out the step, xy times y squared. And then I would add to that, we're going to think of this as the opposite of this term. Okay, so plus, and then we're going to have a xy times the opposite of x squared z. Okay? And then when we multiply that, we will get here, you can think about using your associative property. You can think about regrouping this. I'll even show you that little bit of regrouping. This is all multiplication, so we could regroup it like this, couldn't we? Okay? That would allow us to go ahead and do the y times the y squared. You don't have to write it that way. You can leave it just like this and just know that these two can go ahead and be multiplied. Y times y squared, remember this is a first here. Okay, so that's like y times y times y, so that's y cubed. They're not going to write that first though. And then that's also times x. Plus, now we're going to multiply here. Now we're going to have this negative sign in front of it. Now we're going to do this x times this x squared. That's going to give us x cubed. And then we have a y, and there's no y over here. And then we have a z. And that's your answer here. Now, the book wrote it like this. xy cubed minus x cubed yz. And I would agree that this is simpler to write it this way because you're recognizing this adding the opposite is the same as subtracting. So either of these answers is correct, and I would say this one is the preferred way to write it. All right, let's look at 27.2. We're going to distribute this times this term and then this times this term. You have to distribute it to both terms. Okay, and I'm going to go ahead and write just on this one, and then I'll stop after this one, writing out all of the initial step. Then we'll have adding to that 4xy cubed times a negative 5x. So hopefully you can see this has been distributed to both of the terms. Here's this term is here, and this term, including that negative, is here. Okay? So now we can go ahead and multiply those. 4 we'll take care of here. And then we'll have this x times this x to the 4th, which is, remember, this is a 1. So that's x to the 5th. And then we have this y cubed and a y. Remember, that's a 1. So that's y to the 4th. Now you may be saying, wait a second, those are not like terms. Well, these are not terms. Okay, this is like one big term because it's multiplication. We can't add and subtract things that do not have the same variable raised to the same power, same exponent, but we can multiply them. Okay, so don't get confused there. I know it's going back and forth can get a little confusing. We bring down our plus sign, and then we're going to have this 4 times this negative 5 is negative 20. And this x is to the first, and this x is to the first, so that's x squared. And then this y cubed. Now again, I would say that this could be written simpler by saying that this is 4x to the 5th, y to the 4th, minus 20x squared y cubed. And that would be the simplest way to write that. All right, here's 27(3). Here they moved the number that's being distributed. Okay, see how we've had it out front? Here they moved it to the back. And that's okay because, you know, if you think about arithmetic, 3 times 4 is 12, but that's the same thing as 4 times 3, which is also 12, right? The commutative property. So because of the commutative property, it's totally okay for us to think about this is still the same. Okay, so we're still distributing this to this term and this to this term. And I've had some students who will take this and rewrite it in the front because it bothers them that it's in the back. And that's okay if you want to do that. All right, now, at this point, the book recommends that you don't have to write down that initial step of showing that we multiplied each term by the thing that's being distributed on the outside of the parentheses. You can go straight to this step if you would like. You just have to keep up with a little bit in your head. So that's up to you. It depends. If you're missing these problems, if you miss them on your homework, then you probably should take the time to write that step. Okay? So we're going to go ahead and multiply this term, or else not a term, the factor, by this term that's inside of the parentheses. So we're going to have a 2. We've got an a, and we've got an x squared. These are all multiplied. And then we have this y times this y, which is going to be y squared. So let's make sure we got everything. We got the 2, we got the a, we got the x squared, and we combined the y and the y to give it y squared. Okay? Next thing we're going to do is we're going to multiply this factor by this term here. And we're going to copy down a plus, and then we're going to start multiplying. We know it's going to be negative because the 2 times the negative 4 is negative 8. So we took care of that part. Now we're going to have an x squared. I'm just putting them in alphabetical order. You don't have to, but that just seems to help my brain. So x squared. And then I have this y to the 5th and this y to the 1st, which would be y to the 6th. And again, we can simplify this adding a negative or adding the opposite to subtraction. Okay, and this would be the simplest method. Now, would it be okay if I switched these terms and had this term first and this term after it? Well, not if you wrote 8x squared y to the 6th minus 2ax squared y squared. That negative or that minus has to stay with this. So technically, you could write it like this. And that's exactly the same thing. So this would be an alternate answer, okay? But this is the way you're going to see it in your book. They're going to keep it in the same order that it was given to you. All right, we have one more. We're going to multiply each term on the inside by this factor on the outside. So we're going to multiply the 8 times the 5. That's going to give us 40. M squared times m cubed would be m to the 5th. Remember, adding your exponents when your bases are the same in your multiply. All right, now we have an x times an x, which would be an x squared. Then we're going to add to it, and then we're going to do this times this term, okay? So then we're going to have negative 3 times 8, which would be negative 24. Let's see, we'll do the m first, so m squared. We have this x, oh, and I underlined that as a term, this term, okay? So then I've got the x to the 5th times this x, which is x to the 6th. Okay, and look what snuck in on me here. How many terms do we have? We have one here, and we have another here. So we have to distribute to it. Doesn't matter how many terms you have to distribute that factor on the outside of the parentheses to every term on the inside. So we'll copy down a plus, and then we'll have this 2 times this 8, which is 16. And then we still have our m squared. And then we have this x times this x, which is x squared. And the only thing I would do to clean that up a little bit, and I'm not going to rewrite it, I'm just going to say that plus that I just took away there, plus this negative is really just a subtraction. So this would be your simplest way of writing that. And you can check to see, do I have any like terms? But there are no like terms here that you can add together, because this term, those variables do not match these variables and exponents, and they don't match these. So this would be our final answer.